Power transmission is the result of specific components performing singular functions, each component contributing to the overall task. In order to design and maintain a highly efficient system, a solid understanding of power transmission components is a must. This program will focus on an old and very popular power transmission component, the chain drive. The program will explain why chain is so widely used, detail its advantages, and show how to identify and select the correct size and style of chain. The modern chain drive consists of a driving sprocket, one or more driven sprockets, and an endless chain with hinged joints. The chain transmits power from one sprocket to another. The chain meshes with the sprocket teeth and maintains a constant positive speed ratio between the driving and driven components. The popularity of chain is due to its ability to transmit extremely high torque in relation to cost. Chain drives are widely used because of the many operating advantages when compared to the V-belt. First, chain drives do not slip or creep as do belt drives. As a result, chains maintain a positive speed ratio between the driving and driven shafts. A chain drive requires no tension on the slack side. Therefore, it imposes lower loads on the shaft bearings that would occur with a belt drive. They offer negligible stretching and a long operating life. They can operate in hostile environments, such as high temperatures and moist, oily, and corrosive atmospheres. Chain has unlimited shelf life because it does not deteriorate with age, and is unaffected by sunlight or reasonable ranges of heat and moisture. And chain drives generally can be repaired or replaced without disturbing associated equipment. Drawbacks of chain drives include a higher operating noise than belt or gear drives, a potential for elongation from the wearing of contact surfaces on links and sprocket teeth. Chain's flexibility is limited to a single plane, unlike some belt drives. It has lower speed limitations than belt and gear drives. And when a worn chain is replaced, there is a need to replace sprockets because of wear, unlike V-belt pulleys that undergo very low wear. The application of chain is grouped into two basic functions: power transmission and material handling. Many different chain designs have been developed for unique applications, and dozens of attachments for common power transmission chains have been developed for adaptation to material handling applications. The most widely used style of chain today is the roller chain. This program will feature the construction and numbering system for roller chains. A roller chain is made up of two kinds of links, roller links and pin links, that are alternately spaced throughout the length of the chain. When assembled, the roller chain is measured and identified in pitches. The center distance from one hinged pin to the next is defined as the pitch of the chain. All chain installations require the exact number of pitches before the chain can be sized and installed. A roller link consists of two roller link plates, two bushings, and two rollers. The link plates contain a hole on each end through which the bushings are press-fit, making it impossible for bushings to turn in the link plate as the chain articulates. The pin link consists of a pin link plate into which two pins are pressed, and a pin link plate slipped over the other end of the pins. The roller link and pin link is then joined and secured by either riveting the ends over the plate or by inserting cotter pins through holes in the ends of the chain pins. When the chain is installed, a connecting link or offset link is used to join the chain ends and make the chain continuous. The connecting link is used to make the chain endless with an even number of pitches. To provide for easy installation or removal, the connecting link is joined on a common link plate and held in place with a cotter pin or a spring clip. When an odd number of pitches is required in a drive, an offset link is used to make the chain endless. The offset link is a combination of pin and roller with two offset side plates to accommodate the difference in width between the pin and roller links. A cotter pin is used to secure the offset link. For greater stability than the offset link, a two-pitch offset is often used. The two-pitch offset consists of a standard roller link and an offset link connected by a riveted pin. Chain size, or pitch, is expressed in inches or millimeters. Chain part sizes are proportional to the pitch. As the pitch increases, so does the chain strength, weight, and capacity. The standard industry numbering system for precision roller chain was established by the American National Standards Institute, or ANSI. Standard nomenclature makes the chain and sprockets of different manufacturers interchangeable. A standard chain number is merely a shorthand device that allows a complete identification of an individual chain. Most chains are identified with a 2- or 3-digit ANSI model number. The right-hand digit in the chain designation is 0 for roller chains of the standard series, 1 for a lightweight chain, and 5 for a rollerless bushing chain. The digits to the left denote the total number of 1/8 inches in the pitch. For example, the number 50 chain indicates a 5/8 inch pitch of a standard chain. Number 41 designates a 1/2 inch pitch of a narrow lightweight chain. Number 35 indicates a 3/8 inch pitch rollerless bushing chain. Number 100 indicates a standard series 1 1/4 inches pitch chain. In multiple strand roller chains, for example, a number 60-2 designates 2 strands of a number 60 chain. 60-3 designates a triple strand, and 60-4 a quadruple strand. When the letter H follows a chain number, this indicates a heavy series, with link plates of 1/32 of an inch thicker than a basic chain of the same pitch. By identifying the correct ANSI numbers, all chains and sprockets can be installed and replaced without concern for matching different manufacturers' components. For more information on roller chain, consult the Power Transmission Handbook. While roller chain is the most widely used chain, industry relies on numerous other designs for special applications. Some of these designs include O-ring chain, a variation of roller chain designed for applications where relubrication is difficult, expensive, or impossible. The chain contains small O-rings in each link that seal in lubricant so that wear on internal pins and bushings is minimized. And the O-rings also seal out dirt and moisture, keeping pins and bushings free of damage from abrasion or corrosion. Double pitch roller chain, also known as extended pitch chain. The dimensions are the same as standard roller chain, except the pitch is doubled. Because a given length of double pitch chain contains only half as many pitches, it is lighter and less expensive than standard roller chain, and it is especially suitable for long center distance applications. Engineering steel chain is used to transmit high power with a single strand, often made with steel rollers and used for industrial drives and conveyors. Several types of engineering steel chain are made for different applications. Silent or inverted tooth chain is quieter running and more flexible than conventional roller chain. Silent chain is designed with guide plates that ride in a groove in the center of the sprocket faces. Load capacity is increased by widening silent chain rather than using multiple strands. For more information on other chain designs, consult the Power Transmission Handbook. Proper lubrication is essential for a chain drive to achieve its potential designed life. There are 3 methods of lubrication. The first is Type A or Type 1 lubrication, involving manual or drip lube. This method is most common when the chain is accessible to maintenance personnel, and is most often done by brushing on lubrication, often enough to keep the joints from running dry. This method limits cost, but it is often the least desirable way to lubricate. If the conditions are not severe, and the chain drive is not accessible, then a drip-type reservoir can be utilized to apply small amounts to the chain. The second lubrication method is Type B, or Type 2 lubrication, involving a bath or disc. The bath method employs a case which holds lubricant and allows sections of the chain to run submerged in the oil every revolution of the drive. The disc method applies oil to the chain as it rubs against a disc, brush, or other implement. The third lubrication method is Type C, or Type 3 lubrication, involving flood lubrication. This method employs a constant stream of oil that is pumped under pressure onto the chain. This forced lubrication is preferred for high-speed drives because the oil works into the many crevices and joints in the chain and reduces friction. The majority of industrial drives will usually fall into the Type A or B method. For more information on specific types of drives, check the manufacturer product guides. The number of chain applications is extensive, and because of its simple and effective design principles, the number of chain designs to serve these applications is also extensive. Chain has existed for many years. Its reliability and relative low cost makes it the preferred transmitter of power in many applications. A chain that is properly installed and maintained will prove itself through years of reliable performance in the power transmission process.